Hi everyone, it's Mrs. Smeagol. I have a video for you on stoichiometry. Even if you're not in my class, feel free to watch this video to get a good review, or if you were absent when your class learned stoichiometry, hopefully this will help you out. So the notes I'm going through and the practice problems I'm going through go with this document, Mathematical Thinking and Reactions. So you might have a similar document from your teacher. If you're in my class, you have this exact one. But either way, the video hopefully will be helpful even if you don't have this document to fill out while you watch. All right, so what we're doing in this video is something called stoichiometry. So you should probably say that so you don't sound silly in class if you have to say it. Stoichiometry. And what stoichiometry is it's looking at the quantities of reactants and products, so what you start with and what you make in a chemical reaction. Honestly, it's like looking at a recipe. If I have this many ingredients, how much do I want to make? And so the way I relate stoichiometry to the real world is I think about when you first come home from school. Every day you come home from school, and what's the first thing you do? Some kids say take a nap, and I think that's a lie, because the first thing you do before you even take a nap is you get home, and you open up, oh, look at that pregnant belly. You open up the pantry, and you sit there like this to see if your mom went to Costco. And it's a good day if your mom went to Costco, right? That's the one sad part about growing up. There's lots of sad parts. That's the main sad part about growing up and going away either to college or getting your own apartment. There's no mom who magically goes to Costco. No Costco fairy. So right now, my pantry, pretty boring, because I haven't gone to Costco in a while. And the only way there's going to be good snacks in there is if I go to Costco. But anyways, you get home, you stand in front of the pantry, and you look at what the options are. And so maybe you're looking in your pantry, and you see that you have, a box of mac and cheese in there. Well, to make mac and cheese, you need some milk, you need some butter, and then you need the mac and cheese with the cheese packet, whatever your version is. I just like old school Kraft personally. And so you can look and see how much of these ingredients do we have to actually then make mac and cheese. And how many friends am I having over after school? Do I need to make 2 boxes of mac and cheese to feed everybody? Is 1 enough? Do I even have enough butter to do that? That's what stoichiometry is, but instead of butter and milk and noodles and cheese sauce, it is looking at chemical reactions. So stoichiometry, I also call it stoic, so you'll probably hear stoic in this video. Okay, if you tell your parents that you're learning stoichiometry, if they remember anything about chemistry, they will probably tell you that it's horrible. But that was back in the day. Your parents are old. That's old school stoichiometry. We are going to teach you a way to do stoichiometry that makes it way easier than your parents, maybe even your older siblings, ever learned. Okay, so the strategy we're going to use to solve stoic problems is called a BCA table: before, change, and after. And it will make it so much easier than any horror stories you heard about this being the worst unit in chemistry. In fact, a lot of kids like it. So first step, and in your note packet, you're filling in, I think the red is what you have to fill in. But first step is to balance the chemical equation. And here's the good news. In our class, I'm going to do that for you. So balancing is what we learned last unit, where you have blanks in front of each chemical, and you use your colored dots to make sure that the blue dots on the left match the blue dots on the right, so that you have the same number of chlorines before, the same number of chlorines after. And then you put those big coefficients on the line. So that's done for you. Then, the only way you can use a before, change, and after table, a BCA table, is if your numbers are in moles. So we do have to use some old stuff from last unit. So if I give you a starting amount of a chemical or an ingredient like mac and cheese, cheese, we have to turn that given value grams into moles using our mole island. So we're going to have to find molar mass or be given molar mass, and we're going to have to convert from grams to moles just like it says on your mole island. Then we fill in the before boxes. Once we have that number in moles, we fill out the B of the BCA table. It's like a big chart that we're filling out, and we fill out the before boxes. Those are the ingredients. So the reactants, you are going to have whatever you calculated in moles. And then one of your ingredients is going to be excess. Excess means we have a ton, like a Costco size. So let's say your parents just went to the grocery store and they got a big gallon jug of milk, okay, and I have 1 box of mac and cheese. Well, I might have moles for the pasta, but I have excess milk. I'm not going to run out of milk, right? So that's what excess means. And then the products in the before box always start at 0. Here's why they always start at 0. When I'm just staring blankly into the pantry, I have no cooked mac and cheese. I actually have to do the recipe to make the mac and cheese. So my reactants, my ingredients, I have a starting amount, and then in our class, we're always going to have one that's excess, meaning we have extra of it. And then the products before will always start at 0. That is an assumption we're going to make. Our products always start at 0 because we haven't actually mixed any ingredients yet. Then, after the B boxes are filled out, so that's the first row of your BCA table, then we're going to go to C, which stands for change. The change boxes are like the recipe. How much are we using up of these ingredients? For the reactants, you're always going to subtract something times X. It's a subtraction sign because you use up the reactants. I'm using up some butter, I'm using up some milk, I'm using up some pasta. You get the idea. And on the product boxes, the right side of the arrow, those are always going to be plus something times X. So these numbers plus whatever number X minus whatever number X are going to come from the recipe. And I'll show you an example of that once we have this filled out. Okay, step 4 is the most important step. We have to figure out who the superstar of the recipe is. The superstar is what gives us X. So I call it find X or find the superstar. We're going to take the before, the amount of moles that were given before, and divide it by the change number. The smallest will be our X, and the chemical that gives us X is our superstar. So I'll show you that, I promise. Okay, and then we're going to plug in the superstar and solve for A, which is our BCA. So the last row of our table is the after box. Then whatever the question might be asking for, we select the answer right from the table. And if they ask us to put that unit into grams, we have to do mole island one more time. So sometimes on these problems, you're going to do mole island twice. Once to get into your table and once to get out of the table. If they give you the starting number in moles and just ask for moles, you get to skip those steps, which is nice. And I think we're going to do that on our first one, just so we get used to it. Let's give it a try. All right, so we're going to start with this one, moles to moles. That tells me we get to skip the mole island part, but I'll show you why I know that. Okay, it says the average AA battery contains zinc and manganese to create a voltage. The average battery begins with 5 moles of MnO2. So first, here's the chemical equation. 1 zinc plus 2 MnO2 makes, there's our reaction arrow, 1 ZnO plus 2 Mn. Okay, the first step of my list for stoichiometry steps says balance the chemical equation. That's what these numbers are. 1, 2, 1, 2, the big coefficients. So this has already been done for you, but those numbers are going to be important in a minute. So I wanted to point out that's step 1, is just noticing those numbers. Step 2 says convert the given value. Here's our given value. 5 moles of MnO2. It says convert the given value to moles using mole island and fill in the before boxes. Well, this already is moles. So if this were in grams, we would do some mole island like up here somewhere to show our work. But it's already in moles. So that is my before. The BCA is in this chart right here. So we are filling out the before boxes. This is when you're staring at your pantry, hungry, deciding what to make. So I have 5.00 moles of MnO2 as a starting ingredient. Now, they did not mention this ingredient, Zn, and these are my reactants. Those are my ingredients I have to work with. The right side are my products, the ones that I'm going to be making after I actually cook. Okay, so because they did not mention Zn, I'm going to put excess moles. That means we are assuming that we have so much extra of this that there's no way it's going to run out no matter how many times we do this recipe. Okay, eventually we might put a number there, but this is our first problem. So we're just going to put the word excess. It means we have so much. And then when I'm staring at the fridge and I have tons of milk and 1 box of mac and cheese, or in this case, maybe 5 boxes of mac and cheese, okay, box of mac and cheese means like the pasta. Okay, I don't actually have anything cooked yet. So my products, the right of the arrow, we assume start at 0 mole and 0 mole. So that was step 2, was to convert the given value to moles, which was done for us, already squared away. And then we put our starting moles, excess moles, and the products always start at 0. Step 3 says to fill in the change boxes. So here's what we know. The change boxes are telling us what the recipe is. Like very rarely for a recipe do you need exactly 1 tablespoon of everything. Sometimes you need 3 tablespoons of one ingredient and a cup of another ingredient and a 1/4 teaspoon of this. So the recipe is different for each reactant and product. But here's how it works. We know that these ingredients that we started with 5 moles and excess are going to get used up. So I'm going to do minus, I'm going to leave a little space X, minus, leave a little space X. And we are going to make these products. So I'm going to do plus, leave a little space X, plus, leave a little space X. Now, it's not, just like I said, it's not that we're using the same amount of each of these every time we do the recipe. Where do the numbers in front of X come from? They come from the balanced equation. 1, 2, 1, 2. So really, every time I do a recipe, I'm going to use up 1 times X of this, minus 2 times X, so use up twice as much as the MnO2, and I'm going to make 1X and 2X. So these coefficients are the numbers that get multiplied by the variable X. So in this recipe, we're using twice as much MnO2 as we are Zn. And we're making twice as much Mn as we are making ZnO. That's what these ratios mean. Now, next step says to find, we're on step number 4, find the superstar. So to do that, we take the before number divided by the change number, and we're not worried about the minus sign. That's why I made it a different color. So for Zn, it's easy. We're going to take excess divided by 1. Remember, excess just means like a lot. So a lot divided by 1 is still a lot, excess. And then for MnO2, we have 5 moles as our before number. And then the number in front of X right here, the change number, is 2. 5 divided by 2 is 2.5. Now, we are going to compare these numbers. For right now, you're always comparing excess with a number, and you want to know the smallest. So 2.5 is the smallest, which means it is X. So I'm going to put 2.5 as my X value. And here's the cool part. The chemical that gives me X, which is MnO2, is what we call the superstar. So I'm going to put a star over that so I remember it's all about the superstar. Now we're ready to do step number 5. Plug the superstar and solve for after. So we're going to do minus 1 times X, minus 1 times 2.5. What is negative 1 times 2.5? Well, it's just negative 2.5, so I'm just going to simplify that. Now, minus 2 times 2.5. Notice I'm still in the change box showing my work. Negative 2 times 2.5 is negative 5. Plus 1 times 2.5 gives me plus 2.5. And then plus 2 times 2.5 gives me a positive 5. So I'm just multiplying whatever we found for X, 2.5, by everything. Even though we have different chemicals, it's all about the superstar, and the superstar says X is 2.5. Now, the last part of number 5 says plug in the superstar and solve for after. Well, this is just adding and subtracting. So for zinc, we started in the pantry with excess, so a ton of zinc, and we used up 2.5 moles. How much is left? We're going to say we have excess moles remaining. We had a lot, we used 2.5, we still have a lot. For MnO2, we're just working down the column. We started with 5, we used up 5, we have 0 mole remaining. That should always happen with your superstar. So that's actually something you can fill out once you know who the superstar is. Once you know who the superstar is, it should always end with 0 moles. Just like the products always start with 0 moles. Now, on this side, the products, we started with nothing, but when we actually mix the chemicals, we add 2.5 moles. So 2.5 moles. And then we started with 0 and we add 5 moles. So 5 moles produced. So this is telling me how much leftover we have extra, excess, and 0. And this is telling me how much we made of the products. Now, step number 6 says select the answer from the table and convert the final answer to the unit requested. So this first question says, let's go with this. A battery starts with 5 moles. We already knew that. That's up here. How many moles of Zn does the battery also start with? Well, starting is my before, And here's Zn. How much did we say we started with? Well, we are making the assumption that because they did not mention Zn, we started with excess moles of Zn at start. Okay, now a battery starts with 5 moles of MnO2. We already know that. How many moles of ZnO are formed? Well, here's ZnO. I don't care about how much we started with. If we want to know how much is formed, I'm going to look at the after box. We have 2.5 moles ZnO formed, or sometimes I use the word produced. And then the last question, a battery starts with 5 moles of MnO2. We already know that right here. How many moles of Mn are formed? So here's Mn. We look, we want to know how much is formed, so that's the after row. And we have 5 moles of Mn formed or produced. Okay, in this problem, because they asked for moles, 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 we did not have to show any work for mole island to go from mole island to mass island in this part of the problem. So we're done. We solved the stoichiometry. We solved the BCA table. Remember, before is what you have in your pantry. Change is the recipe that we're following, and it'll tell us how much we're using up and how much we're making. And then after, we're just adding or subtracting. I say B plus or minus C makes A. So if it's subtraction, B minus C makes A. If it's adding, B plus C makes A. All right, I'll go through this one a little faster. So it says a chemist begins with 7 moles of HF. First step, we got to check, okay, we have all these coefficients, so my equation is balanced. That's step 1. Now we can fill out the before. We start with 7 moles. This is already in moles. We're only allowed to have moles in our BCA table. Okay, they did not mention this other chemical at the beginning, SiO2, the other reactant, so we're going to assume it's excess moles. And we always assume that the products, the right side of the arrow, no matter how many different products there are, start at 0 moles. Now we do our change. Minus X, plus X, and plus X. Remember, the reactants get subtracted because we're using those ingredients up. The products get added. And we used our balance equations to put these numbers, 1, 4, 1, 2. That's coming from here. 1, 4, 1, 2. Now, before we plug in, we need to know what X is. So we're going to go down to the bottom of our table where it says find X. And we're going to take the before divided by the number in front of X, before divided by the number in front of X. So we have excess divided by 1, that equals excess. And then we have 7 divided by 4. 7 divided by 4 gives us 1.75. We are comparing these two numbers. The smaller one wins, and that is our X, which means the chemical that gave us X, HF, is our superstar. So X is 1.75 according to the superstar. So we're going to do minus 1 times 1.75, so that's minus 1.75. We're going to do minus 4 times 1.75. When I take negative 4 times 1.75, that's a negative 7. Plus 1 times 1.75, so plus 1.75, plus 2 times 1.75. So that would be plus 3.5. Now we do B minus C equals A, or B plus C if there's an add sign. Excess minus 1.75. So we have a lot, and we only use up 1.75. We're going to have excess mole. We have 7 moles, and we use up 7. I have 0 moles remaining of HF. I start with nothing when I begin cooking, and I made 1.75 moles, so I have 1.75 moles. I start with nothing, and I make 3.5, so I have 3.5 moles. Next step, chemist begins with 7 moles. We already knew that. How many moles of SiO2 remain? So here's SiO2. I don't want to know how many we start with. I want to know how many remain. That's after. So we have excess mole SiO2 remain. That's how much is left over. Eventually, we I went backwards. There we go. Eventually, we will have a number here and we will have a number here, not the word excess, but that's why we're comparing. I know it seems silly. Excess will always be bigger than this number, but once we have a number here, this process will be a good habit. So you're always picking for x, the smaller when you do your find x steps. And right now, I know it seems silly to write the word excess, but eventually next unit, you might have a number there. Now, a chemist begins with 7 moles of HF. We already know that. How many moles of SiF4 are formed? So here's SiF4. We don't care about how much was made. We don't care about the recipe. We care how much was formed right here. And they want just moles, so no mole island. 1.75 moles of SiF4 produced, or you could say formed, same thing. And then a chemist begins with 7 moles of HF. We already know that. How many moles of H2O are formed? So here's H2O. After box tells me how much we make. So we get 3.50 mole H2O produced or formed. Great. All right. I think you're probably ready to do one of those on your own, but example 3 is what I call a backwards problem. So we are going to do it together. Okay. Here's what it says. A chemist has made 4 moles of Ag. So first step we check, is our equation balanced? 3, 1, 3, 1. Yep, there's those coefficients. But here's the trick. If we make 4 moles of Ag, here's Ag. And remember, our products always start with 0. We haven't actually cooked anything. So they're telling me they're making 4 moles of Ag produced. So they're actually giving me a number down here instead of up here. I bet you they're going to ask for some of these. So here's what we're going to do now. We're going to fill out what we can. We don't know these yet, right? We don't know these yet, but we can figure them out if we say, let's assume that both of these hit 0. They're both essentially the superstar. They're both going to run out of 0. Neither are excess. Because then when we solve, they will tell us the exact amount we need up here for the recipe to make 4 moles, right? So we're basically thinking each of these, how much do we need in order to make 4 moles? How much of this do I need to make 4 moles? And the only way that works is if both of these perfectly run out. Now, we're going to do our change boxes. We're still going to use up minus 3 times x of this, minus 1 times x of this. So it does not change your plus or minus signs. We still are going to use up whatever amount we start with. We just don't know that yet. And then plus 3 times x for this guy, and plus 1 times x for this guy. Now, to find x, we're still going to take the given number of moles and divide by the change. And I'm allowed to put this 4 moles down here because it's what they said we made that much, so it goes in the after, and it's in moles. It wasn't in grams. So to find x, we're going to take the given number, and this is for Ag, the given number 4 divided by the change of 3. So it just looks a little backwards. Normally we take this number divided by 3, this number divided by 1. And we can only do that for Ag because that's the only one we have information on. Okay, 4 divided by 3 is 1.33, and that's going to equal x. So x is 1.33. Now we plug in minus 3 times 1.33 gives me minus 4. Minus 1 times 1.33 gives me negative 1.33, plus 3 times 1.33 gives me positive 4, and plus 1 times 1.33, 1 times 1.33 is positive 1.33. Okay, let's fill out what we can. On this side, 0 plus 4 is 4. That makes sense. That means we did it right. 0 plus 1.33 is 1.33 moles of the AlCl3 produced. Now, on this one, we just have to think logically. I have a certain amount before. I used up 4, and I ended with 0. That means this must be 4 moles to start. And then on this one, I had some number here to start. I used up 1.33 and we ended at 0. So that means this has to be 1.33 moles if we wanted both of these to perfectly run out. Now, the final question says, A chemist made 4 moles of Ag. We knew that already. How many moles of AgCl did they start with? So here's the part I care about. It's not how much we ended with, how much did we start with? And they want the answer in moles, so no mole island needed. 4 moles AgCl to start. Perfect. So for a backwards problem, we still have the assumptions that the products start at 0, but now we're going to assume that both reactants run out. They both hit 0, and then the only difference is we start with a number here, so to find x, we take that number divided by the coefficient, 4 divided by 3. But then everything else was pretty much the same. All right, here's a little review for you, because we're going to need this for the next part of our BCA table when I give you numbers in grams instead of moles. So I have 2 compounds here, MnO2 and ZnO. First one, first row says calculate the molar mass. So this is where we need our periodic table. We find Mn on our periodic table. It has a mass of 54.02. We find oxygen on our periodic table. There are 2 oxygens in this formula because of that 2. We times it by the mass of oxygen from the periodic table. So I take 54.02 plus 2 times 16, and I get 86.94 grams per mole as the molar mass. Some teachers write it as this, 86.94 grams equals 1 mole. That means the same exact thing as grams/mole. This is the same as this. Now, it says use molar masses to convert from moles to grams. So same chemical. This is where we take out our mole island from last unit. We need to go from mole island, because they gave me 0.125 moles, and turn it to mass island. Here's what I know. I know that 1 mole equals 86 grams. They gave me way less than 1 mole. 0.125 is way less than 1. So I'm expecting this answer to be less than 86. But let's do mole island to actually get the number. So we start with the given number in front, 0.125 moles. If we look at our mole island, we set up our empty bunk beds. We want to get grams. Our bunk beds say to put 1 mole on bottom and the molar mass, 86.94 grams on top. So I'm using this molar mass. In my calculator, I'm going to take 0.125 times 86.94, and I get 10.87 grams. That's what goes up here. And that is way less than the 86. Now we're going to go the other way. Use molar masses to convert from grams to moles. So this time we are going from mass island to mole island, because we don't know the moles. And this time we have 6.4 grams. That's way less than 86, so I expect my number to be smaller than 1, because we know 86 grams is 1 mole. We have way less than 86 grams, so we expect way less than 1 mole. But let's solve it out. We take the given number out in front. Let's go with green. 6.4 grams. Set up your bunk beds. And we want mole. On your bunk beds, when you travel from mass island to mole island, we put 1 mole on top and the molar mass in grams, 86.94 grams, on the bottom. In your calculator, you take 6.4 times 1, hit enter, divide that by 86.94, so your units cancel, and we get 0.074 mole, really small, 0.074. Now, here's what I would like you to do. I need you to pause the video, and you need to solve for the molar mass of ZnO. You need to do mole island to go from moles to grams, and then mole island to go from grams to moles. So really, pause the video. I'm not going to put up the answers. In fact, teachers in the room, maybe you can check kids off once they have these 3 done before they hit play again. See, I wasn't lying. I didn't put up the answers. You got to check with your teacher. Okay, so now we can't measure things in moles because we don't have like a scale or a balance or a graduated cylinder or something that tells us moles, but we can measure things in grams. So a lot of times when we do a lab, we measure in grams, and then we want to do our stoichiometry, our BCA table. So we have to convert from grams to moles to get into the BCA chart. No grams ever allowed in the BCA chart. Then we go at the end, because our BCA chart gives us moles, we might need to go from moles to grams to get out of the BCA table if they're asking for our answer in grams. Okay, so you're doing mole island at the beginning and you're doing mole island at the end of these BCA charts because no grams allowed, only moles in the BCA table. All right, our reaction begins with 10 grams of aluminum solid. So here's aluminum solid. Okay, first step though is always to check that we're balanced. 3, 1, 3, 1. We are balanced, so that's good. Now, we are not allowed to take 10 grams and put it right here because there are no grams allowed in the BCA table. So look, up here, we added a new box for you. It says get into our BCA table. So we need to go from mass island to mole island because we can only have moles in the BCA table. So we're going to take our given number, 10.00 grams, and I'll put AL just so we don't forget. I'm going to set up my empty bunk beds, and we want moles of AL. Now, here's the good news. In the last problem, we had to find molar mass for the bunk beds. But look right here, molar masses. This 143.32 is the molar mass of this chemical. 26.98, the molar mass of this chemical. 107, you get the idea. So they are giving us the molar mass. 26.98 grams equals 1 mole, or you can write it as gram/mole. So I'm going to take that number, and to go from mass island to mole island, we put the mass, 26.98 grams on the bottom, 1 mole on top. So in my calculator, I take 10 times 1, hit enter, and then divide that by 26.98, and I get 0.37 moles. That is now our starting number. So we are only allowed to take those moles to get into our BCA table. But now we're in. So let's put in our assumptions. They did not give me a starting amount of AgCl, so we assume that it's excess moles. And then the products we assume always start with 0 moles. We have minus 3 times x, minus 1 times x, plus 3 times x because we make those products. That's our delicious mac and cheese. And plus 1 times x. Remember, these numbers are coming from the balanced equation right here. 1, there we go. Okay, now we need to find x. So we're going to use... So to find x, we're going to use the givens. So we have AgCl, and we take the before divided by this red coefficient. No, don't worry about pluses or minuses. So excess divided by 3 is excess, and we're going to do the same with the aluminum. Al, 0.37 divided by 1, that's just 0.37. That is the smaller excess versus 0.37, so we're comparing excess with this, and the smaller one is our X. The chemical that gives us X, aluminum, is our superstar, so I'm going to star that guy. Now, it's all about the superstar, so we plug in the superstar's X. Minus 3 times 0.37, that's negative 1.11. Minus 1 times 0.37, that's negative 0.37. Plus 3 times 0.37, that's plus 1.11, and plus 1 times 0.37, multiply those, we get 0.37. Now, B minus C equals A or B plus C equals A. That tells us from our recipe, we started with this, we're using this much up. Excess minus 1.11 is still excess. We're not going to run out. 0.37 minus 0.37 is 0 moles. That's good. We should always hit 0 for our superstar. And then we started with nothing and we made plus 1.11, so 1.11 moles. And we started with nothing and we made 0.37 moles. Now we got some extra work this time. It says we start with 10 grams of aluminum. We knew that. How many grams of AgCl are needed? Okay, so first thing, we started with excess AgCl. We ended with excess, but they want to know how much we need for this reaction to work. So the idea here is like I have a huge Costco size of peanut butter for my PB&Js, but I need to use a little bit. Like how much should I take out of the jar? Well, we are using from the recipe negative 1.11, but really the negative just tells us we're making it. So, and we want this to be in grams. So we need to go from mole to mass island. And we're going to start with 1.11 mole, and it's AgCl. set up our empty bunk beds. You're just showing your work down here, and we want this to be grams. Okay, when we go from mole to mass island, it says to put 1 mole on bottom and the molar mass on top, and they gave us the molar mass, 143.32. So in my calculator, I'm going to take 1.11 times 143.32, hit enter, divide that by 1, and I get 159.09 grams of AgCl. Okay, that one was a little tricky because we had to use from the recipe how much. They're basically saying how much do you need for the recipe. This one should be more straightforward. How many grams of Ag are formed? So here's Ag. If we want formed, we go down here. We still have to go from mole to mass island. So I take 1.11 mole of Ag, set up my bunk beds. We want grams of Ag. We got to put 1 mole on bottom and the molar mass, 107.87. So I'm using the individual molar mass for whatever chemical they're asking for. So in my calculator, I'm going to take 1.11 times 107.87, hit enter, and then divide that by 1. I get 119.74 grams of Ag. Last one. How many grams of AlCl3 are formed? So here's AlCl3. Here's my formed, but that's moles. So we got to do mole island, 1 mole on the bottom, molar mass, 133.34 grams on top. And we want to get grams of AlCl3. When I multiply 0.37 times the molar mass, hit enter, divide by 1, I get 49.34 grams. Sorry, that's hard to read. Perfect. All right, for this one, I want you to try. So you're going to start by noticing your balancing. Then you're going to turn grams to moles over here to get into our BCA table. You're going to solve your BCA table, got to figure out who X is, and then you're going to do from moles to grams for this product, moles to grams for this product. Give it a try, pause the video. No, really, pause the video. All right, just a reminder, you check your balancing. Yep, it's there. We are not allowed to put 16.4 grams under MnO2. It has to be moles. So over here where it says get into your BCA table, that is a big hint that you have to do mole island. So we're going to go mass island to mole island, and that's the number for our starting ingredient. And then we fill out our assumptions. We assume Zn is excess. You assume your products start at 0. We assume we use up these guys, minus 1x minus 2x from the balanced equation, and these guys get pluses because we're making the products. Now, it's your turn to find x, so we got to take excess divided by 1, 0.19 divided by 2, and pick the smaller one and plug it in as x, solve out your after box, and then you can do mole island down here. So pause the video again to finish. Make sure you're on track. All right. So I need you to show your work for finding x and you to show your work for plugging in. Do not leave this. Where the yellow is, you are showing work. And so I just put these numbers in for you to check. Excess 0.095 moles produced, 0.19 moles produced. And then you need to show mole island work. For the blue, how many grams of ZNO? Here's the moles. You have to go from mole island to mass island using molar mass. Check your answer. And then for green, here's your moles. You have to do mole island to mass island using this molar mass up here. Check your answer. If you have something wrong, call the teacher. All right, this is your last one for start to finish. I am not putting up the answer. You need to check your answer with your teacher and their answer key before you pack up for the day, or if you were absent, when you return to class. Hopefully this was, I know it's kind of long, but hopefully this was a good way to learn Stoich. And if you were absent from class, keep you caught up and feeling better about stoichiometry and BCA tables.